Right, so in this example, we just want to get comfortable with using the notation for functions, and along the way, kind of use that notation to understand a little bit about how functions work. So in this example, we're given three different functions whose names are f, g, and h. The first function is f of x is equal to 4 plus the square root of x minus 2. The second, g of x is equal to x squared plus 1 over x plus 1. And the third, h of x is the absolute value of negative 12 plus 9x. And the problem asks us to do nothing more than to find some numerical values, f of 7, g of negative 3, and h of 2/3, and to simplify our answers as much as possible. And we really just want to get comfortable with using and contextualizing the notation that we're using here to describe these functions. So the strategy is to remember one thing about functions. Functions are verbs. They're actions. They're not nouns. They're not quantities. They're not numbers. Instead, they're processes. They're rules. They're things that do, not things that are. And so what I like to think about when evaluating functions is we're going to think of replacing the x which defines these functions with the input that's desired for the function everywhere that that x appears. We'll see what that looks like in a minute. In other words, it's going to be a process of substitution. We're going to be substituting numerical values into the expressions which define these functions. And anytime we're doing a substitution, using parentheses is always a good idea to make sure that what was originally happening to the x will be happening to your entire thing that you're substituting for x. And then once we've done that substitution, it's just a matter of simplifying the result. In this particular problem, because our inputs are all numbers, we're going to be able to use the order of operations in arithmetic to completely simplify the results to get a single number at the end of each problem. So here's my take on functions. The question in part A asks us to find f parentheses 7, and we're going to screw that up unless we remember what that means. So what is a function? A function is a verb. It's something that happens. It's a process. It's not a noun. It's not a quantity. It's not a number, but it's a rule. It's a process. It's a set of things that happens to an input in order to produce an output. So if I use x as an input to this function whose name is f, we're going to think of f as being like a little machine. And x is put in at the top of this machine as an input. And out the bottom of this machine comes an expression. So inside this machine, a bunch of stuff happens to x, and then it spits out this value, 4 plus the square root of x minus 2. So for example, inside this machine, we're going to take whatever input we get, and we're going to subtract 2 to it. And then we're going to take the square root of what we have. Then we're going to add 4 to that number, and then we're going to spit out the answer. So that's what f is. It's that process of what just happened to the input to turn it into the output. And because f is a function, if we put in an input, we're only going to get one output for each input that we put in. And this expression, 4 plus the square root of x minus 2, is called f parentheses x. But when you read that in English, what not to call it is don't call it f times x. This is one of the most unfortunate things about functions, is that the notation that we use for the process of evaluating a function is the same as the notation that we would use for the process of multiplying numbers. But that's not what this is. F parentheses x, if f is the name of a function, should be read not as f times x, but as f of x, or if we want to be really verbose, f applied to x. So it's the process, it's the verb f happening to the input x. And with that in mind, if we have f parentheses 7, what we're really doing is we're taking that rule f, the process f, and using the number 7 as an input to that process. So if we input x into the function f, then we know what we get out. We get 4 plus the square root of x minus 2. If we instead put a y into the function f, then what we would get out of f is 4 plus the square root of y minus 2. And we would call that expression f of y, or f applied to y. So whatever we put into f, we get 4 plus the square root of that thing minus 2 as output. And so this question is no more than asking us to put a 7 in as input to our function. And if I put a 7 in, what I'm going to get out is 4 plus the square root of 7 minus 2. And that's the quantity that we call f of 7, or f applied to 7. And then it's just a matter of simplifying what we have. 7 minus 2 underneath the radical becomes 5. And so f of 7, or f applied to 7, or the output from f when the input is 7, is 4 plus the square root of 5. So that was a long-winded explanation of what will become a more second nature process for you. That we had a function which was defined by this equation, this formula up here on the top. F of x is equal to 4 plus the square root of x minus 2. So what f does is it subtracts 2, takes the square root, and then adds 4 to whatever you plug into it. And so this question is just asking us to do that with 7 as the input. And so f of 7 is 4 plus the square root of 7 minus 2, which we can simplify to 4 plus the square root of 5. There's not going to be anything particularly new in parts B and C where we're doing substitutions for the functions g and h instead. For example, if I want to know what g of negative 3 is, I first have to know that g of x, or g applied to x, gives you the expression x squared plus 1 over x plus 1. So whatever you put into the g machine is going to get squared and increased by 1, and then divided by the result of that original thing increased by 1 by itself. So x squared plus 1 over x plus 1 is what g applied to x comes out to be. And so in this equation, in this problem, we just want to put in a negative 3 for x. Here's another place where we're making a substitution, and we should really use parentheses when we make that substitution. In fact, it's probably a good idea to always use parentheses when you make a substitution of any kind. We've seen in a number of places previously that can get you into trouble otherwise. So when I substitute this negative 3 in for x, I'm going to hug it with a set of parentheses both times. And the expression that I get there is what we're going to call g of negative 3. And now it's just a matter of performing the arithmetic steps using the order of operations to simplify this fraction. Negative 3 squared plus 1 is going to be 9 plus 1. Negative 3 plus 1 in the denominator is going to be negative 2. And so my fraction simplifies to 10 over negative 2. And if we do that division problem, we get negative 5. So g of negative 3, because g of x is x squared plus 1 over x plus 1, g of negative 3 is negative 3 squared plus 1 over negative 3 plus 1, which simplifies to 9 plus 1 over negative 3 plus 1. That's 10 over negative 2, or negative 5. Finally, the h machine. According to our definition given to us in the problem, h is the machine which takes an input x and produces the absolute value of negative 12 plus 9x. So it takes the input, it multiplies it by 9, it adds it to negative 12, and then it takes the absolute value of the result. So if h of x is negative 12 plus 9x in absolute value, then h of 2/3 is the absolute value of negative 12 plus 9 times 2/3. Again, hugging that input with parentheses. So now all we have to do is simplify. 9 times 2/3 inside the parentheses is 6. So we'll have the absolute value of negative 12 plus 6. Negative 12 plus 6 is negative 6, and the absolute value of negative 6 is positive 6. So because h of x is the absolute value of negative 12 plus 9x, that means that h of 2/3 is the absolute value of negative 12 plus 9 times 2/3, which simplifies to the absolute value of negative 12 plus 6, which is the absolute value of negative 6, which is 6. So the most important skill here is to know what it means to be given the definition of a function in a formula. Giving you a formula that defines a function, nothing more than specifies a template, a rule, for what to do with an input to that function. You do with an input to that function whatever the formula does with the x. So in the example of f, what do you do with an input? You subtract 2 from it, you take the square root of the result, and you add 4. In other words, you replace the x in that expression by whatever your input is. So we wanted to know what f of 7 was in part A, so we replaced the x by a 7 and then simplified. In part B, we were given this expression for g of x. And if we wanted to know what g of negative 3 is, we replaced the x's by negative 3 and simplified the expression to get negative 5. And finally, we were given this definition for the function h, and we wanted to know what is h applied to 2/3. So we replaced the x's by 2/3 and simplified the results to get 6. So evaluating a function is doing nothing more than asking what is the result of applying this process to this particular input? How do we apply the rule F to the input 7? How do we apply the rule G to the input -3? How do we apply the rule H to the input 2/3? And it is always a process of substitution rather than multiplication, despite the fact that we use parentheses for this notation. So this is something that will take a little bit of getting used to. But the more of these problems that you do, the more that it will become second nature, and the less out of water you will feel when this happens to you in pre-calculus next semester.